Okay, Bismillahirrahmanirrahim. Assalamualaikum and good morning. Apa khabar semua?
Waalaikumsalam. Khabar baik.
Okey ke? Dah bercuti seminggu okey kot? Ke tak recharge lagi? Ada banyak assignment ke?
Okey.
Test hari tu boleh jawab tak? Saya tak marking lagi. Saya punya part. Tapi saya bagi yang lecture-lecture lain dulu marking. Sebab saya quite busy. Tapi nanti saya akan marking lah juga. Sebab semua pensyarah yang mengajar akan marking. So, macam mana? Boleh jawab tak hari tu? Semua diam ya?
Boleh.
Boleh kan? Alhamdulillah, bolehlah insyaAllah. InsyaAllah saya doakan. Alright, okay, today we will continue our lecture for chapter 3. Okay, as you know, chapter 3 it's not included in our assessment for either test 1 or test 2. But it will assess for project. Okay, I hope that all of you have your own group. Okay, please make sure that you list your group members. Okay, in the WhatsApp group. Okay, then if I'm not mistaken, the other group have already give their group members, except for your group. You are 4A1, right? So I need to recheck. Okay, please make sure by this week, okay, you have all your group members, 5, okay, maximum 5 per group. Okay, then the other assessment in this chapter will be your quiz. It's 10 marks, okay, and the question could be combination between theory and calculation, but it's inobjective. Okay, means that A, B, C, D. Okay, multiple choice question. Okay, so I will recheck with the CC, course coordinator, the exact date for the quiz. Okay, so I think that's for the chapter 3. Okay, so now we look at the, okay, any question before we start class? Class. Any question before we start? Tak ada ya? Alright, okay. So notes ni nanti saya share dalam future. Nanti boleh tengok ataupun saya bagi dalam WhatsApp group pun boleh. Boleh nampak ya? Kelas?
Boleh Doktor.
Right, okay. So this is basically for the activity that we will do. Okay, for the shallow should be start at the week 8. It's not 7, 8. But you have study week. So today is this week is the week 9, right? Betul? Okay. So first of all, okay, kita akan tengok satu video, okay, relate kepada kita punya chapter lah. Okay, so this is relate to the how the skyscraper are built. Okay, so apa dia maksud ni? Saya nak you all tengok. Okay, ni saya agak video yang agak penting. Mungkin dah ada di antara you all yang dah tengok pun dekat YouTube Tapi cuba tengok ni. Boleh dapat ke? Boleh nampak ke?
If you have tried countless money games, MLM programs, research,
first modern skyscraper was built in 1885, and since then, these monoliths of architecture have stood as marvels of our engineering capabilities. The Burj 722 feet into the air and
Dengan
is
suara
built
je.
on top of one of the
Dengan
worst
suara je.
foundations in the
Tak apa.
world.
Saya buka semula
Its
sekejap ya.
construction required 192 steel piles, each 164 feet long, and a foundation made from 110,000 tons of concrete. You might be
Tall buildings are prevented from falling over and
Tak nampak lagi?
Nampak.
Ada kan?
the first modern skyscraper was built in 1885, and since then, these monoliths of architecture have stood as marvels of our engineering capabilities. The Burj Khalifa, the world's tallest skyscraper, stretches 2,722 feet into the air and is built on top of one of the worst foundations in the world, sand. Its construction required 192 steel piles, each 164 feet long, and a foundation made from 110,000 tons of concrete. You might be asking how such tall buildings are prevented from falling over in high winds or tilting under the force of the floors above the foundation. To answer that, let's take a closer look at how skyscrapers are made. Today, skyscrapers are commonly defined as buildings that have more than 40 to 50 floors, though the world's first modern skyscraper, the Home Insurance Building in Chicago, Illinois, had only 10 stories. The definition of the skyscraper has shifted over the years as engineering capabilities have gotten better. Skyscrapers are one of the most efficient uses of space in a crowded city, but they present a plethora of engineering challenges. One of the biggest challenges modern skyscrapers face is the fight against one of Earth's most basic forces, gravity. As buildings get taller, the foundation and bottom floors have to hold more and more weight. That is why when it comes to skyscraper construction, one of the most important aspects is building a solid foundation. Many skyscrapers are built on bedrock, the layer of subsurface rock that is largely immune to shifting. In cases where bedrock is available to be built on, engineers will dig down to that level and anchor the foundation to the bedrock with steel or reinforced concrete columns. However, being able to construct a skyscraper on bedrock is something that is specific to geography and geology. In many places, bedrock isn't close to the surface. The Burj Khalifa, for example, had only very weak sandstone accessible to it due to the region's sandy nature. In this case, engineers had to use a series of long piles driven into the ground. This is another common skyscraper foundation technique, and it's based solely on the principle of friction. Rather than constructing the building on bedrock, the building sits on hundreds of piles that use friction forces from the sand to keep them from sliding down. This pile foundation doesn't technically rest on bedrock. Rather, it's just the friction between the sand and soil that keeps them from moving. After the foundation is built, usually using large amounts of concrete, then engineers can start building up. Advances in steel are largely what have allowed modern skyscrapers to come into existence. Skyscrapers are essentially built out as steel skeletons before all of the windows and exterior structure is added. There are beams and vertical columns connecting each floor, held together by rivets and bolts. Steel functions well in both compression and tension, whereas concrete really only works under compression loading. The ability of steel to be used in both tension and compression makes it perfect for engineering large spans in skyscrapers. All of the weight and force is transferred through the steel to the ground, where it's distributed through the concrete foundation. Once the steel skeleton and core is built, the rest is essentially just decoration. However, modern skyscrapers also have many things that work against them. These include wind and earthquakes. Skyscrapers' biggest daily threat is the wind forces causing them to wobble or crack. Engineers protect skyscrapers against the wind in two main ways. In many cases, the actual design of the building is altered to make it more aerodynamic. Back to the Burj Khalifa, this building was actually designed to minimize vibration wind loading, making the net wind force on the building essentially cancel out. However, not every skyscraper can be as geometrically interesting as the Burj Khalifa. Most modern skyscrapers will have something called a tuned mass damper. This is essentially a giant pendulum that sits near the top of the skyscraper and acts as a counterweight to absorb and cancel out the forces from the wind. And that's essentially how engineers do it. Through the advances in modern steel, concrete, and construction practices, humankind will likely continue to reach onward and upward through the construction of skyscrapers.
Okey kelas. Okey, semua dah tengok tadi. Alright, kejap ya saya buka balik your slide. Okey. Okay, so based on video tadi, apa yang you all faham? Untuk high-rise building, apa yang you all nampak?
Piling.
Yes lah, the important of piling tu. Tapi how they in term of the distribution, load distribution, macam mana dia bangunan-bangunan tinggi macam tu? Melalui apa sebenarnya?
Foundation.
Nah, dari mana? Daripada atas tu, kamu nampak tadi dia gunakan steel, betul?
Yeah.
So dia itu jugalah macam step pembinaan high rise building. Okay, itu yang saya minta you all fahamkan yang skyscraper tu. Okay, skyscraper. Alright. So this is the, ada banyak lagi video lain. Okay, nanti you all pun boleh tengoklah video lain tu tentang macam mana pembinaan bangunan-bangunan tinggi dan kenapa pentingnya foundation, sebab foundation ni dia akan menjadi satu asas penting untuk safety ataupun untuk bangunan tersebut ataupun building yang dibina. Alright, so this is the LO for this chapter. Okay, determine the bearing capacity of soil below shallow foundation. Okay, we have the appropriate formula. So for this one, we will have the exercise also. So I will give you the exercise, the example, okay, how to do, and to formulate and determine size of footing, to identify the parameter, and to formulate the determine settlement of shallow foundation. All right. So this is OOP of the presentation. Okay, and this is the introduction. How to differentiate between the shallow and also the deep foundation. Okay, usually we may say that if the less than 3 or 4 meter, we can categorize as a shallow foundation. Okay, more than that, we categorize as a deep foundation. Okay, so the foundation itself is actually when you refer to the to support, okay, based on the structure, which is, as I mentioned just now, the distribution of load, okay, and how the load will transmitted to the underground, okay. So then this is the example of foundation. Okay, we have the shallow and also we have the deep foundation. So you may see here, this is the example of shallow foundation, isolated footing, straight footing, and rough foundation. Okay, rough, we may also use the terms mat foundation. Okay, and we have the deep foundation, bore pile, high steel. Okay, is the H. Okay, H steel pile. Okay, and also Kaisen pile. Okay, this is also one of the foundation under the deep foundation category. Okay, this is as I mentioned just now. Okay, is the depth. Okay, the depth is less than 3 meter. Usually we may consider or we may categorize this type of foundation as a shallow. Okay, whereas is more than that. Okay, more than 4. Okay, so this is we consider as a the deep, okay, the deep foundation. All right. Okay, next one. All right. So this is when you refer to the design requirement or the concept of design for the foundation itself. Okay, currently we are referring to the BS. Okay, we have the Code of Practice for Foundation for the BS 8004. This is in 2015. And also we have the alteration at 2020. Okay, A1 2020 Code of Practice for Foundation, and also BS 8103 for the structural design of low-rise buildings. Okay, why low-rise building? Because this is under categories of the shallow foundation itself. Okay, then we also have the Euro Code, okay, geotechnical design, and I think if I'm not mistaken, you also have one subject, okay, in the structural design. I'm not sure. You ada ambil ke belum structural design? Belum kot. Part 4 belum ambil kan? Dah ambil ke? Kelas?
Belum. Steel design dia?
Dah ada lah, steel design ada lah.
Steel and beam design.
Oh, dah ada lah kan, steel and beam design. Dah belajar? Semester bila? Semester ni? Oh, dah ada lah kan? Belajar dengan siapa? Ayah Samizi?
Dr. Rohana tak silap.
Oh, Dr. Hana. Oh, okay. Apa tak apa. Okay, this relate also lah, okay, untuk design requirement itself. But in this chapter, kita tak ada belajar detail untuk design, okay, because it's not included in our syllabus. In our syllabus, more to the calculation of the bearing capacity, okay, because ecg553 is more to the application, okay, more to the application based on the field condition. All right. So next is the factors that design of shallow foundation. Okay, they have 3 criteria that we need to be considered. Okay, the first one is the adequate depth, limiting settlement, and FOS. For sure, FOS is a very important thing. Okay, even though we fulfill the first 2, but if you fail to fulfill the number 3 criteria, so means that it's also will fail. Okay, the design juga akan tidak dapat dibuat dengan baik. Alright, so this is the factors as I mentioned just now. So the depth must be sufficient. So means that even though ada sebarang changes, sebarang macam contoh angin ke, the climate changes ke dan sebagainya, dia tidak akan merubah pada untuk keadaan tersebut. So dia means dia kena deal dengan any moments. Okay, so bersesuaian. Okay, dia punya kedalaman itu adalah bersesuaian. And then limiting settlement, okay, the amount of total settlement, differential and angular deviation that may be tolerated, okay, depending on the functional performance of the building. So apa maksud total settlement, differential dan sebagainya ni? Kita tengok contoh di sini. Okay, this is the, we can say that the settlement, okay, ni boleh nampak ke ni ke kena besarkan? Boleh nampak kan? Tulisan dia agak kelabu. Alright. Okay. So here you may see that, okay, this point A dash, C dash, okay, and B dash. Alright. So here, okay, the settlement, okay, we have the S of P here, okay, is the downward displacement of a given point. Example, settlement of the point B. Okay, settlement of the point B. This is the point B, right? Settlement of the point B. Differential settlement is the displacement of one point with respect to another. Okay, means that the displacement of B with respect to the A. So this is the meanings by the differential settlement. And angular strain at the given point is changed in the slope at the point. Example that alpha A equal to, okay, we have here, this is the alpha A. Okay, so you may refer to this diagram. Okay, so how is the angle? Is the we can see that the angle delta is the rigid body rotation angle. Okay, so then we also have this relative rotation, relative deflection. By the way, this is not to the most important definition that you need to understand is the what's the meaning by the downward displacement and also the differential settlement itself. Okay, this is a quite important terms. All right. Okay, then okay, here this is the again limiting settlement. Okay, we have the guideline given by Scampton and McDonald is 1956. So this is the guideline for the sand and also clay. So means that when we design the foundation, we need to know what is the type of soil. Okay, how we will know the type of soil based on the SI report. So from the SI report, we know that the characteristic of the soil, okay, either is the in the categories of sand or clay. Okay, so means that for the sand, we need to design the maximum total settlement is a 40 mm. For the isolated footings, 40 to 65 mm for rough. Okay, if you still remember what I'm saying to you in the previous chapter, for the settlement, we measure in mm. Mm is for millimeter. Even though your calculation, maybe if you still remember when you do the measurement, okay, if you get meter, you need to convert to mm because for the settlement, we measure in the mm. Okay, maximum differential settlement that we allow 25 mm for the sand. Okay, by the way, if you refer to the clay, maximum total settlement is 65 for the isolated footing and 65 to 100 for the rough footing. And the maximum differential settlement we allow is a 40 meter. Okay. All right. So then this is the shear failure. Okay, shear failure when it's related with the FOS. Okay, because just now we have the three criteria. Okay, we're referring to this. Depth, limiting settlement, and FOS. And as I mentioned just now, the most important part is actually the FOS. Okay, even though you fulfill the first two, but you are not fulfill this third category, so means that you are failed. Your design still considered as failed. Okay, failed design. So here, you need to make sure that the maximum mobilized shear stress must not be less than the appropriate value. Okay, so this is meanings by the FOS, the factor of safety. So now, so how, this is by one of the previous researcher, okay, Versick in 1975, okay. Okay, kita semua pun tak lahir masa tu lagi. Okay, how to decide FOS number? Category A, characteristic of category. Okay, maximum design load. Okay, likely to occur often. Okay, consequence of the failure. Okay, this is the category A. So instead of SI, okay, site investigation, we have typical structure. This is the structure that usually use this category, which is we use the railway, bridge, warehouse, okay, retaining walls, okay. And the B, the maximum design load may occur occasionally. So this is the likely to occur often. So this is the different. So this is for light industrial, public building, and also highway bridge. Then the third one is for the maximum design load. Okay, this is apartments or office building. So this is the how we want to decide the FOS number for the for the design purposes. Okay, so next one is the modes of the shear failure. We have the general mode of the shear failure. We have the local shear failure, and we have the punching shear failure. All right, so I think that you have seen this, okay, in the other notes also. Okay, so if general here, you may refer that, you can see that here, this is a quite lateral, okay? This is the general. And for the local itself, okay, is only at this area. It's not include, okay, for the above area. And the punching here, the area is more in the confined zone at this part only, from this point to this point. And when you refer to this, okay, this also different between the general and also the local and the punching. Okay, that's the different illustration. All right, so this is what I mentioned just now. For the general, you may see that they have the for the left side and the right side. Okay, you just look at the arrow there. Okay, the arrow there. And for the local, okay, the area is not like the lecture just now. Okay, this is more bigger, general. But in this case, okay, it's end within the soil. Okay, it's end within the soil. Dia tak ada pergi ke atas-atas ni. And then for the punching shear failure, you may see that the arrow is a downward arrow here. If you're referring to the previous slide, they have the arrow which is the for the right side and the left side here. Okay, the right side and the left side. For the first one also, we have the left side, right side, and also the downward. But for this one, local, we only have at the within the soil. Okay, not until this layer. And for the last one, we only have the downward. We do not have the left and right side. Okay, for the development. Okay, so this is the type of failure normally occurs in the very loose cohesionless soil. I really hope that you still remember what's the meaning by the cohesive and also cohesionless soil. All right. So this is the points that you need to take into account. Okay. So what's the meaning by the general shear failure, what's the meaning by the local shear failure, and also the punching shear failure, right? Then next one is the definition of the bearing capacity. Okay, previously for the, I'm not talking about the ODL, for the face-to-face class, this is the quite popular theoretical part question in the final exam. Okay, just to assess either the student really need to understand the definition of each term in the bearing capacity. Okay, for example, we have the QF, ultimate bearing capacity. We have the QN. Still remember class, the QN? As we see in our previous lecture. QN tu apa? Class? Saya kadang-kadang kena tanya juga, nanti saya seorang je cakap-cakap kat sini. Korang tak dengar pun. QN tu apa Farah? Farah Farzana? Farah? Farah Farzana? QN tu apa? Dah lama sangat ni. Sejam je. Okay. Farah? Dah dapat belum? Ha? Apa dia? Tak ingat? Siapa yang ingat? QN apa dia? QN apa dia? Takkan tak ada yang ingat? QN equal to? Ada tulis kat situ tu. Ha? Ingat tak? N tu apa dia? N tu apa kelas?
Net.
Q net. So Q net, how to get the Q net? Banyak kali sangat dah cakap benda ni. Macam mana dapat?
Q tolak sigma dash naught.
Apa dia akhir?
Q tolak sigma dash naught.
Q minus?
Sigma dash naught.
Gamma.
Gamma.
Okay. D. Gamma D, right?
Betul. Sigma dash naught gamma D.
Betul lah tu. Sama lah juga. Gamma D. Sigma dash naught. Okay. So factor of safety against shear failure, F4S. And you also need to know the presumed bearing value and also allowable bearing capacity, the QA. Okay. So this is the formula. Okay. Formula ultimate bearing capacity. Okay. We have the, usually for the equation, okay, they will give to you the equation. Okay. Give also the equation. And here you may see that, okay, the Q, okay, the Q is the intensity of the bearing pressure, and the NC, NQ, and gamma is the bearing capacity factors. So the bearing capacity factors, they have 3 different ways that to get this value. First, the value of NC, NQ, and gamma is given in the equation. So means that if they give you some case of the equation, so it's given to you that NC equal to 37, for example. NQ 28, N gamma is 36, for example. So means that you just use whatever value given in the equation to answer the equation. Second, you need to find the value of NC, NQ, and gamma using the table. So in order to find the value of NC, NQ, and gamma in the table, you need to know the value of phi value of soil. Okay, the phi value of soil will given in the question. It will given to you the phi value of soil. When it's given the phi value of soil, then by using the phi value of soil, then you will know how to get the value of NC, how to get the value of N gamma, and also how to get the value of NQ. Alright. Then the third one, okay, I hope that you remember this, okay? First, second, and third. The third one, you may find the value of NC, NQ, and gamma using the graph. Using the graph will provide, okay, in the question. Okay, so now any one of you may repeat what I explained just now. They have three different ways to get the value of NC, NQ, and gamma. Siapa boleh tolong?
Ada soalan.
Okay.
Daripada
Amir ni macam tak makan pagi, cuma bangun tidur je suara Amir ni.
suara pagi serak-serak.
Oh, suara pagi serak-serak. Baguslah Amir. Saya takut-takut bangun-bangun tidur terus masuk je mic. Okay Amir. First, apa? Diberi dalam soalan. Okay, second?
Daripada table.
Menggunakan table. So, in order to get yang menggunakan table ni, kita kena ada apa?
Angle, phi.
Yes, good. Third?
Daripada graph.
Apa dia Amir?
Daripada graph.
Alright, so tengok pada graf. So tengok pada graf ni juga adalah dengan menggunakan phi value. Boleh faham? Boleh faham tak kelas?
Boleh.
Ada 3 cara. Okay, so that's the 3 cara untuk kita mendapatkan nilai N, nilai apa saya beritahu tadi? Okay, they have 3 different ways to get the NC, NQ, and gamma. Okay, so means that we couldn't assume this value. Okay, they have 3 different ways. Okay, first given in the question, second in the using the table, and the third one from the graph. Okay, then we also have here the equation by Terzaghi. Okay, kalau you all tengok kat sini dia ada first term, second term, third term. So apa maksud first term, second term, third term ni sebenarnya adalah untuk membezakan, okay, untuk equation sebut untuk mudah diingati. Okay, because the first term is actually refer to the QC itself. Okay, QC, if you refer here, the straight CNC, the square 1.3 CNC, the circular 1.3 CNC, the rectangular CNC. So this is the first term. Okay, to make it more clear. And second term, okay, this is the Q. So YQ here is referring to the NQ. NQ. Okay, so means that sigma dash naught NQ. So this is the for NQ. And the third term is for gamma. That's why we have 0.5 B gamma and gamma, 0.4 B gamma and gamma, 0.3 B gamma and gamma. So this is all the equation for the straight, square, circular, rectangular. Okay. For the equation, sometimes it's given to you the type of soil, and also it's given to you Allah Akbar. Saya ada kelas lah. Sekejap saya balas mesej sekejap. Dia suruh saya datang meeting sekarang. Tak boleh. Ini ada kelas. Alright, okay. So here, okay, even though this equation is 1943, dah lama sangat-sangat. Okay, but until today kita memang tak adalah yang ubahkan equation ni, memang kita ikut this equation. Dia dah establish, okay, dan memang dah banyak sangat-sangat design bangunan pun memang still lagi menggunakan ni. That's why kalau kamu tengok di sini, bearing capacity factors depending on angle phi of the soil. So macam mana nak dapat angle phi of the soil tu? Based on the soil parameter. Okay, based on the soil parameter. So here Okay, ini yang dimaksudkan dengan first term, okay, for the cohesion, second term for the surcharge, okay, because the Q, and third term for the unit weight of the soil. So, means that untuk mendapatkan a bearing capacity ataupun bearing pressure of the soil, kita kena consider adanya cohesion kat situ, adanya surcharge kat situ, dan adanya unit weight dekat situ. Jelas tak kelas? Jelas? Saya cakap sorang-sorang je ke?
Yes.
Saya tak cakap sorang-sorang kan? Saya sebenarnya tak
Tak.
sabar nak tengok result test 1 korang ni sebab dalam kelas saya tanya faham. Saya takut tak tahu macam mana korang, faham korang tu macam mana kan. Harap okey lah result tu. Alright, okay. Then this is the, if we categorize that the soil is semi-infinite, homogeneous, okay, isotropic. So this is the type of soil. Okay. So then in this case, okay, we may refer to this figure, okay. Saya kecilkan semula sebab nampak besar. Okay. Alright. So this is the, if you're referring to the gamma D, okay, if you still remember the gamma D, means that we have in this, okay, in this diagram itself, you may refer that the unit weight of soil. So the unit weight of soil itself, okay, when you're referring to this diagram, you have the we may see that the F, the active, passive, radial, passive here. This is the related to the shear failure itself, the condition, okay, of the shear failure itself. So now, why is mentioned that the soil above the footing, the soil above the footing. So where's the footing? Okay, where's the footing? The soil above the footing base can be replaced by a surcharge stress equal to gamma D. Gamma D also is referring to what, class? Sigma? Yes, good. So I think that you understand now. Alhamdulillah. So this is the table. Okay, so what's the difference? They have two different table. They have for this one, this table of bearing capacity coefficient for general shear failure using this value by these three researchers, okay, by Frandy, Resner, and also Hansen. But the most popular table, we are using this. Not this one also. Okay, this one. Terzaghi. Okay, Terzaghi bearing capacity. Okay, Terzaghi bearing capacity factors. So in this table, okay, you need to refer to the equation. If the equation asking you, usually for the table, they will put in the attached appendix, right? So you may refer, if they are given to you the Terzaghi bearing capacity factors, so you just refer to the Terzaghi bearing capacity factors. If the table given to you is for after Frandis, after Resner, and after Hansen, so you may refer to this table. But the most important thing when you get the table, in order to answer the question to find the bearing capacity factor for the soil, you need to know what is the value of the phi value of the soil. Okay, for example here, if your phi value of soil, for example, is 24. So this is a 24. Okay, so you know that your value of NC equal to 19.3. NQ class? Okay, and gamma?
6.89.
All right, so this is how we find the value. Same goes to here. Okay, we need to find what is the phi value of the soil. Just now is we referring to the 25, right? 24. Okay, 24. So now we go for the 24. Okay, here. Okay, what is the value for NC class?
23.36.
Okay, NQ?
Level 0.4.
And gamma? Okay, is same or not?
No.
And different.
Yes, it's different. Why different? Because we are using the table. Okay. Allahu Akbar. Ya Rabbi ya Karim. Okay. Saya kecilkan sikit. Okay. So here, okay, why different? Because this table comes from the different researchers. Okay. So here is the, as I mentioned, the value for these three researchers. Okay. And we also have the value for the Terzaghi. By the way, the most popular appendix that we are referring is actually from the Terzaghi bearing capacity. Okay, so then this one is the modified bearing capacity factor. So the modified one means that they already modified the coefficient of the bearing capacity itself. So same goes here if you refer to the 24 value of phi. Okay, it's also different comparing to the previous slide. So here, the most important thing, no need to worry which table that you want to use. The most important thing that when the table given to you in the appendix, you know that how to start. Means that first thing you need to find the phi value of the psi. Then from the phi value of the psi, you may find the NC, NQ, and gamma. Then barulah boleh jawab soalan. Jelas kelas? Boleh faham tak?
Boleh.
Boleh faham ya? Janganlah seorang je, yang lain boleh faham tak?
Faham.
Okay, good. Alright, so kalau ada soalan tolong tanya ya. Alright, so then after that, we go for the ultimate stability design. Okay, this ultimate stability design for the shallow foundation, this given by Debier and also Besic in 1967 and 1970. So this is the equation. So again, for this equation, what's the difference is actually they have the shape factors. So what is the shape factors? Shape factors given by the SC, NQ, and gamma. Here, the SC, SQ, S, gamma. The rest is same with the previous equation. So, macam mana kita nak dapatkan SC, SQ, S, gamma? For sure, they also given to you the appendix. Okay, for this one. Okay, this is the shape factors for the shallow foundation in order to get the value of SC, SQ, and also S, gamma. Okay, for example, based on the equation is the street footing. Okay, for the street footing, you may strictly take a SC, SQ, S, gamma equal to 1. By the way, for example, your shape of footing is rectangle. If the rectangle, so you need to use this equation. Okay, you need to use this equation. Means that one is a constant value. Okay, you need to find the B over L of the footing itself, the dimension of the footing, and also the NQ and also gamma is based on the table given to you. So from here, you know that what is the value of your SC. Okay, same goes to the S gamma, SQ, and same goes to the S gamma. So means that this table will given to you together with the bearing capacity factors table and also the equation involved. And then you may answer the question. All right. So then after we calculate all these things, actually which bearing capacity equation to use? Okay. This is the this is the tak nampak saya punya ni.
Tak nampak doktor.
Dah lama ke?
Baru je.
Doktor baru masuk table.
Line doktor.
Kenapa ya? Kenapa
Line
dia hilang?
doktor.
Line doktor terputus tadi.
Lah, kenapa line saya terputus? Ke sebab macam-macam lah. Saya memang kalau line kat office ni memanglah dia masalah sikit. Nampak tak? Saya share yang ini ke tadi? Saya share yang ini ke tadi? Betul?
Tadi slide atas tadi.
Yang inilah.
Slide
atas
29.
Yang ini. Yang ini dah terputus dah tadi.
Doktor terputus waktu masuk tu.
Betul, kenapa tak cakap? Diam je semua. Mana saya manalah perasan sebab saya tengok slide, saya tak tengok mic. Saya tengok slide je. Alright, okay. This is the equation, okay. And it's mentioned here, values of gamma dash changes depending on the position of the groundwater. So, bagaimana ini berlaku? Ini saya beritahu. Yang ini yang akan saya bagi kamu example. Okay, kita tak sempat lah hari ni. Hari ni tak sempat. By the way, I will given to you, alright. Okay, so how it works? Okay, here, this is a reduction in the gamma dash due to the groundwater. So here you may refer that sigma dash naught. Masih ingat lagi kan? And then gamma dash. They have 5 different location at the ground surface. Okay, ini yang kamu nampak 1, 2, 3 Romans tu. Okay, at the ground surface, this is at the intermediate, this is at base of foundation. Okay, within B that. Okay, above passive zone. So where is the passive zone? This is a passive zone. Okay, passive zone below the B deck. Okay, this is the B deck. Okay. B deck, okay, below the passive zone. Alright. Second term is a sigma dash naught and Q. So sigma dash naught and Q here, you need to know that how to get the sigma dash naught. Ingat lagi tak kelas? How to get the sigma dash naught class? Very good Afif. Okay, gamma D. Saya harap yang lain pun ingat ya. So sigma dash naught here is the gamma D. Okay, gamma D. And then the NQ. How to get the NQ class? How to get the NQ class?
Tengok table ke.
Ada 3 cara, betul?
Betul.
Yang saya beritahu tadi kan? Ingat tak? Ke dah lupa dah? Baru lagi ni belajar ni. Ingat tak 3 cara tu, Amir?
Ingat.
Ingat.
Ingat kan? Okey. Amira ingat? Amira Kairina ingat?
Ingat.
Ingat Betul Apa dia?
Dia beri dan soalan. Lepas tu satu tengok table. Satu lagi tengok graf.
Okey, yang tengok table dengan tengok graf tu kena ada value apa?
Yang tengok table tu kena ada angle C.
Okey. C?
Yang
Apa A? Phi value of the soil. Okey? Jangan silap Nanti kamu ambil pula nilai lain. So here, dia ada equation dekat sini. Okay. Sigma dash naught equal to gamma D. Inilah yang saya beritahu ni. Inilah yang akan kita lihat dalam example nanti. Saya akan bagi example satu persatu keadaan ini. So nanti you all akan tengok juga what's the meanings by if there is an upward component of seepage flow of a hydraulic gradient I, the effective unit weight gamma dash must be further reduced. So apa yang dimaksudkan dengan I gamma water? So what is the I itself? Okay, the I itself is referring to the hydraulic gradient. Okay, hydraulic gradient. So In order to complete this equation, you need to know that the value of hydraulic gradient first, okay, the I, and also the effective unit weight gamma dash. So then it's given by the amount equal to I times with gamma water. Okay, you may referring to the week low are page 464. By the way, we are not enough time today, but next week I will give to you the example from the beginning. In order to get all this value, okay, saya harap dalam example sebut kalau tak faham, tolong tanya. Saya nak semua faham. Okay, saya bukan nak seorang, dua orang, tiga orang, saya nak semua faham. Boleh? Boleh kelas?
Boleh.
Boleh.
Alright, so we end our class today. Okay, dah pukul 11. Okay, saya ada kelas lain pula. Okay, so before we end this session, ada soalan ke? Saya akan bagi rotan sekejap lagi ya. Saya bagi dalam group. And then make sure you all punya group members ya. Tak bagi lagi kat saya kan? Betul ke?
Belum lagi.
Tolong bagi. Boleh tak by this week? Tolong ya. By this week ya. Untuk projek 5 orang satu group. So saya nak nama tu ada dalam group WhatsApp by this week. Boleh kelas?
Boleh.
Alright. Okay, terima kasih banyak-banyak. Alright.